This video is to go over lesson 6.5 on review packet 6A. First it says write each number in scientific notation. So let me do the first one, which is A. That's 10,000. So the scientific notation is we only have ones and the decimals, and then multiply by 10 to the some power. So we're going to change this. We're going to take the ones. We have this. We have 1 times 10 to the fifth power, right? Yep, because we have 1, 2, 3, 4. No, it's the 10 to the fourth power. Sorry, fourth. And let me do E. E will be, we want to have 7.3 because we have 0.73 and times 10 to the 1, 2 negative second power because you're going backwards. That's the idea of that. Next page. Write each number in decimal notation, so it's backwards. So we have, let's see, A is 1.86 times 10 to the 6th power. So 1.86. We're gonna move this decimal 6 times to the right. So go 1, 2, 3, 4, 5, 6. So we have 186,000,000. So it's 1,860,000. How about C? That's 8.46 times 10 to the negative 4th power. So we're going backwards. So I go 1, 2, 3, 4. So this is the decimal points. So we have 0.000846. Next. That's it. Number 14. The planets are consistently in motion, so that the distance between Earth and other astronomical object is constantly changing. The table shows the average distance between Earth and the few astronomical object. Okay. A garden snail moves at rate of about 3 times 10 to the negative second power miles per hour. If a garden snails could fly through space at that rate, okay, how many hours would it take to reach the moon, to reach Mars, to reach Neptune? Okay. So let me do the moons. So the distance between those two will be 2.3 times 10 to the 4th power. That means 2.3, and then move the decimal 4 times. So 1, 2, 3, 4. So that's 1, 2, 3, 4. So it's 23,000 miles. And then the snail moves 3 times. 3 times 10 to the negative second power. So that's 3. We have decimal point right here. So 1, 2. So 0.03. So every hour the snail moves 0.03 miles. And then the next hour it will be 0.6. Right? Miles, hour and miles. 1 hour, 0.03. Second hour, 0.06, and so on and so forth. If you go to 23,000 we use K, just like 2K13 for the video game. K stands for thousands. So 23K. So what would that be? How can we find that out? Okay, next problem. Express each quotient in notation. Oh, by the way, problem number 14, not just the moon. Find out, well, once you solve the moons, then you can use the same rules for Mars and other planets. So apply that rule. 16, express each quotient in scientific notation. So let me do A. So we have 9 times 10 to the 10th and 3 times 10 to the 2nd. So we have 10 copies of 10 upstairs, and then downstairs we have 2 copies of that. So first of all, we can kind of break that fraction into 2 parts, like this. You know, it's the same thing. So now everybody can do 9 divided by 3. So that's 3. And then this part, we have 10 copies of 10. Picture that. You know, I don't want to write that down, but you have 10 copies of 10, and you have 2 copies of 10. And actually, let me just do that. 10 times 10 times 10 times, 10 copies of that over 10 times 10 times. Okay, so that's 2 copies of that. If you look at this one, we can make 1 because 10 divided by 10 is 1. So we have 3 times 10 divided by 10 times 10 divided by 10. And then upstairs we have some copies of 10. Downstairs we have nothing. That means we have 1. So here this is 1 and this is 1, and then 3 times 1 times 1 is 3. So that's 3. Times how many copies we left here? 8 copies of it, right? Because we have 2 copies here and we have 10 in total, so I have 8 copies of that. So 8 copies of 10 divided by 1 is itself, because you divided the number by itself by 1, so we should get the number by itself. So 3 times 10 to the 8th power. And use these rules to find out other problems. Alright, good luck.